Okay, here we need to be looking at SI derived units. Now, when we say derived units, we mean derived from the SI base units, which was the subject of an earlier video. Okay, let's have a look at some common SI derived units. Perhaps I could put the units in here, like so. Move across. We can have a symbol for each unit. And then perhaps we could just put the name in here for you just to make it clear what we're doing. Okay. So the unit, first one I'd like to look at is the Coulomb, symbol capital C, and it's to do with electrical charge. Okay, so the charge on perhaps an electron or a positron, or even an ion or a group of charges, so it's all measured in coulombs. Okay, so electrical charge. Right, another one. We can look at degrees Celsius, perhaps. So degrees Celsius, you've all seen this symbol, degree C, and of course that is a measure of temperature. Sometimes we use degrees Kelvin, other times we like to use Celsius, it depends. And just to elaborate on that, so degrees Kelvin, take away 273.15 degrees Kelvin is equal to so many degrees centigrade. Okay, so that one dealt with. We also have a unit called Farad, named after Michael Faraday, capital F for symbol, and of course this is a unit we use to relate capacitance, so capacitance between 2 points or 2 parallel plates separated by a dielectric perhaps. Okay, so into electrical circuits now. So a Henry, H, and this is to do with inductance or coils, if you will. Okay, inductance. There are many derived units. I'm just going to go over some of the more useful ones for you. They're the ones you'll come across a bit more frequently. Hertz. Symbol is Hz. And of course this is frequency. So you've heard of kilohertz and megahertz, and gigahertz, etc. That's the SI derived unit. Okay, let's have a look at the joule. Okay, most of these are named after famous scientists, capital J. And joules, well, it's a measure of energy slash work done, or perhaps heat, etc. Okay, a lumen. Lumen, lowercase lm, this is to do with luminous flux, which is a bit analogous to magnetic flux, which no doubt you've seen the earlier video to do with magnetic flux. We have another one, lux, Lx, and this is to do with illuminance. Now, illuminance is how brightly a surface is illuminated. Okay, so if you shine a torch on a white table, it's going to show up brighter than if you did it on a dark table. Okay, so how much light is retained by that particular surface? Let's have a look at a Newton. capital N, as many of you know. Okay, and this is connected with force or weight, because weight is force. Okay, I'm running out of space down here, so I'm just going to add a few more. An ohm, symbol is omega, and this is to do with resistance, measured in ohms, or use slash, inductive or capacitive reactance. Reactance is measured in ohms, as is impedance. Okay, so impedance is a combination of resistance and reactance. Okay, I've just got a few more I'd like to discuss with you. I'll just extend this table down a bit. Another Pascal. PA is the symbol. And this is mainly to do with pressure or stress. It's not pressure over stress, it's just pressure or stress, okay. Radian. Radian, we give it the symbol rad. And of course this is to do with angle. Okay, that's the more modern way to represent angles, certainly for signals. Okay. Siemens, capital S. We've all heard of the famous German company, Siemens, named after, obviously, another famous scientist. And Siemens is a measure of electrical conductance. Which is usually 1 over resistance, or 1 over reactance, or 1 over impedance, depending on what you're dealing with. Okay. So it's a bit like more or less the opposite to resistance, really. So conductance is how well a component will allow electrons to conduct or flow through itself, whereas resistance is a measure of how well the component tends to block as best as it can the flow of electrons through itself. Just a few more now. Tesla, name of a famous electrical car manufacturer these days, another famous scientist. Tesla measured a capital, symbol is capital T, and it's a measure of magnetic, I'll just abbreviate that, magnetic flux density. Okay. 3 more. Volt. You've all heard of volts, of course. Just extend this table a little bit. Capital V for volts. It's just voltage. So the voltage across a battery, the voltage coming from the main supply to your house, etc. Okay. The watt. Symbol is capital W, and watt is the symbol we use for power, or in the light world, radiant flux. And last but no least, I did say there are plenty of them, but this is the last one I want to mention here for you, is the Weber. Again, another famous scientist, capital W, lowercase b. This is not magnetic flux density, but this one is magnetic flux itself is measured in Webers. Okay, so I'll just go all the way back up to the top. There's quite a number of them there. They're the main ones that you're going to find in the scientific world. And as I said, they're all derived from the SI base units, which is the subject of an earlier video. Okay, well, hopefully that's been useful for you, and Thanks for watching. See you next time.